This lesson is going to look at creating and analyzing two-way tables. A two-way table is used to identify and record observations of categorical data. So like scatter plots, those were looking for quantitative data or data that was numerical, measured in numbers. This time we're looking at data in categories, like favorite color, or if you're a boy or a girl, or subject in school, things that are not necessarily measured in numbers. So let's take a look at the two-way table. In a two-way table, the sum of the column totals equal the sum of the row totals. And remember, sum means addition. So sometimes you're going to see two-way tables like this. This two-way table has two pieces of information. It has your gender going up and down, whether you're male or you're female, and then it has your science class going across left and right. Notice at the end of the columns and at the bottom row, both of them say total. So the columns, if you add them together, all should equal the grand total of 80, and the same things with all rows. If you add all the rows together, it should equal the grand total of 80 because it tells you that 80 seniors were asked what science class they were taking. So normally there's more things to fill in besides two in a two-way table, but I'm going to take a look at how to find a couple of pieces of data here. Let's take a look at the females in physics, this column right here. Let's look at that and see if we can find the total there. So if I'm looking for my value there, I can recognize that I have 47 females total. I know that 18 and them are in biology and 15 of them are in chemistry. I want to know how many are in physics. So I can add the ones in biology and chemistry together. So I have 18 plus 15. 8 plus 5 gives me 13. I carry the 1. 1 plus 1 plus 1 is 3. So that's 33 girls that are in biology and chemistry. In order for me to figure out how many are in physics, I have to take a total, which is 47, and subtract the ones that we've already used, which is the 33. 7 minus 3 is 4, and 4 minus 3 is 1. So that means then that there are 14 girls that are in physics. So I can find now the total in physics, because a total is I can take the number of girls and the number of boys and I can add them together. So I have 14 plus 19, which would give me 4 plus 9 is 13, and 1 plus 1 plus 1 is 3. So that means there would be 33 students who are in physics. Let's say I went the other way and I didn't know how many females were in physics. In order to find the 14, I could have taken the total 33 and I could have subtracted the males that are in physics, the 19, and I could have come up with the same thing, the 14. So I could have had to borrow, because I can't take 9 from 3, so that would have become a 13, and the 3 a 2. 13 minus 9 is 4, and 2 minus 1 is 1. So then that would tell me again that there are 14 females in physics. So I could have done this numerous ways. So there are numerous ways to fill in the values from each particular section of the two-way table. So let's look at the part 2 of the two-way table. Now that we know how to fill them in, can we interpret the data that's in them? So in order to determine percentages that the two-way tables represent, you have to divide the category, I call the category personally the part, by the whole. So your division problem becomes the part divided by the whole. So when you're asked a question, there's a key word in this. You're going to see the word of more often than not, and then there's going to be something that comes after of. Whatever comes after of is considered your whole, and that's what goes in the denominator or the bottom part of your fraction or your division problem. So let's take a look at some of these values. So we have the same two-way table as before, but we want to calculate, it says what percent of all the males are taking chemistry. My keyword is of, and after of comes all the males. So if I was making my division problem as a fraction, all of the males total is 47. So I have 47 males. I want to know how many of them, though, are taking chemistry. So I'm going to look in the male row, and then I know that 18 of them are taking chemistry. So on your calculator, you would divide 18 by 47. and you're interested only in the first couple of decimal numbers. So I have 0.3829. In order to make a decimal into an actual percentage, I have to take my decimal point from the front and I have to move it 2 spaces to the right. So if I move it 1, it becomes between the 3 and the 8, and if I move it 2 spaces, it becomes between the 8 and the 2. So I'm looking at 38.29. And I want to round my percentage for what we're doing to the nearest tenth. So the 2 is in the tenths position, it's the first number after the decimal, so I'm cutting it off here. Remember, when you round, if it's 5 or higher, you round up, and if it's 4 or lower, you leave it the same. So since 9 is strong enough to push the 2 up because it's 5 or higher, it's going to be 38.3%. Let's look at one more example. So let's look at what percent of, again, keyword is of, after of comes all students. That's my denominator. All students, the total is 80. I want to know how many of them are taking physics. So I look at my physics column. I have 33 girls and boys in physics. So I want to take my calculator and divide 33 by 80. The first couple of decimal digits I get are 0.4125. If I take the decimal and we get a percent by moving it twice to the right, I go once, twice, the decimal is now between the 1 and the 2, so I have 41.25. I want to round again to the nearest tenth, so I'm rounding where the 2 is, so I'm cutting the number off there. And then is the 5 strong enough to push the 2 up? It is just barely, right? Because if it's 5 or higher, you round up. So in that case, I would have 41 and 3/10% of all students are taking physics.